So today we are going to discuss next portion of our first unit, close packing of spheres. Now close packing of spheres can be done in three ways. One in one dimension, second in two dimensions, and third in three dimensions. So let us first do it for first one dimension. So very first thing is we consider atom as a sphere. So if we are talking about one dimension, then we have to keep our spheres or atoms in such a way that they form a single line. Okay, this type of arrangement, if you see any atom you take, that will be in touch with two other atoms. Okay, so that particular number, as many atoms touch a given sphere, is known as coordination number. Okay, so in one dimension it is just a row of atoms. In this arrangement you can say it is a row of atoms. This is a row of atoms. So it is in one dimension and the coordination number is 2 only for this. Now in two dimensions, in case of two dimensions, there are two different ways. Now what we have to do, in one dimension there was a single line of spheres. We have to place one line over the other. So placing can be done in two ways. Here in this diagram it is shown that we are placing the next layer over the previous layer as it is. Their axis, it is placed horizontally as well as vertically. See, the spheres of two rows are aligned horizontally as well as vertically. See, horizontally also they are same and vertically also they are same. So in this way if we are going to do, then a particular given sphere will be in touch with four other spheres. So coordination number value will be 4. Now the second is also there. Here theoretically it is written. In case of second thing, what is there? When we see a single row, see this is our single row. Now in this single row, this thing, this particular portion, it is called as depression. This is called depression. Now second way is to place the rows of to place the next row over the depressions of first row. Okay, so see this diagram. Now what we have done, we have placed this row is placed over the depressions in this row. So in this row there are depressions. Okay, these are the depressions. Okay. Now over these depressions we have placed the next row. Now whatever are the depressions of next row, the next row is also placed over the depressions. So in this way if we do, then there will be 6 atoms which are in touch with the given atom. So coordination number in this case will be 6. The previous one coordination number was 4. So previous one was called square close packing in 2 dimensions and it is called hexagonal close packing in 2 dimensions. Here we have talked about 2 dimensions only. Now let us come for 3 dimensions. Now in 3 dimensions there are 3 different ways. Very first is we are going to place, now see, first of all, in 3 dimensions what is to be done? In 2 dimensions what we did, we took a row, we placed another row and another row. This combination of rows, it is called a layer. Now in 3 dimensions what we have to do, we have to take these layers and over one layer we have to place another layer, then another layer. This way we have to see. Okay, so now layers are to be placed. Now placing of layers can be done in 3 ways. How it can be done? See, very first way. See, this is the thing. Now what I have done, we have taken this layer, then this layer, then this layer, then this layer. Here placing is exactly in such a way that vertical and horizontal thing is maintained. See, this is vertical, same vertical position, same horizontal position. If we are doing this, then this type of thing is obtained, and this is called simple cubic lattice, in which we will say this layer and this layer, all layers are same aligned, they are on the same axis, so it is called AAA type of arrangement. And since a cube is formed, so it is AAA type of arrangement, in which all the three continuous layers are on the same axis. Okay, now let us come for next one. Okay, now see, two different ways are also there now, which will lead to hexagonal close packing. This previous one was square close packing in 3 dimensions. Okay, this is called square close packing in 3 dimensions. Okay, now for hexagonal close packing in 3 dimensions, there are 2 different ways. First thing is, let us move to the diagram. See, now this is our first layer, and this thick one is second layer. We have shown only 2 layers here. On first layer, if we see, there are 2 types of vacant spaces. Now just see the lower layer. This is vacant space. We can say these are lower vacant spaces. Now this is also vacant space in the very first layer, down layer we are talking about now. So this thing means that if we see, same type of vacant spaces will be formed in the second row also. Now those which I have shown in the lower one, second layer we are placing over this. Placing of second layer is done in such a way that lower vacant space is covered by the upper sphere. Now if it is done, then what happens? Then 2 types of vacant spaces are formed. How? See, if I take these 4 spheres I am talking about, then these 4 spheres are touching each other, and there is still vacant space. Here there is vacant space. This vacant space is called tetrahedral wide. Now if you see this side, I am taking these 3. See, these 3 are from the lower layer. Okay, not these 3 exactly. Let me take these 3, 1, 2 and 3. Okay, these 3, this triangle which I have made, it is connecting the centers of the spheres of the lower layer. Now if I see the centers of the spheres of upper layer, then it will be like this. Okay, now these 3 spheres from the lower layer and 3 spheres from the upper layer, they are touching each other, and still there is presence of vacant space. Here there is vacant space. Now this is called octahedral wide or octahedral hole. Now see, here what is to be remembered? The vacant space which was there in the bottom spheres, on that particular vacant space itself there is one more vacant space which is formed by the upper spheres. So it is octahedral hole has vacant space at the lower spheres also and upper spheres also. So this is to be remembered. Here in case of tetrahedral, there is just one vacant space. So tetrahedral means only 4 are touching each other. Here octahedral means 6 are touching each other. So this one is octahedral wide, this one is tetrahedral wide. So there is formation of tetrahedral wide as well as octahedral wide. Now there are 2 possibilities of placing the third layer. If I take similar type of layer which we can see here, then we place by considering upper vacant space as center. Then what is going to happen? See here which I have circled. If I will place the third layer by taking this as the center, then what is going to happen? This third sphere and this first sphere, they will be in the same axis. Only the middle layer that will have sphere somewhere else. Okay, but third and first, they will have same on the same axis, they will be having their centers. So first and second is different, but third and first are same. So this is called AB 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 type of packing. Okay, this will be AB AB type of packing. Now the next one, if I place the third layer by considering, okay, now see, if I place the third layer by considering this as center, see, if I consider this as center, this one as center, then what is going to happen? This is the center of the first layer, this is the center of sphere of the second layer, and this is going to be the center of sphere of third layer. So all these three are on different axes. So what type of combination is formed? ABC ABC. Okay, so two types of things are formed. This one is AB 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 type, okay, and this one is ABC 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 type of form. Now see which vacant spaces we talked about. This much shows tetrahedral wide. Okay, these three spheres are of the first layer and this is of the second layer. Now when we are going to place this, the vacant space will still remain here, it is not going to cover the whole space. So that vacant space is called tetrahedral hole. Similarly, if these three spheres are from the lower layer, these three are from the upper layer, then we will place them reciprocal way, in a reciprocal way, then even then there will be vacant space. That vacant space is called octahedral wide. So this is what we discussed. So kindly go through this all, and on the basis of this you have to perform, you have to do these home assignments, you have to define this and you have to do this. Okay, so kindly go through this video at least twice.